So now this is what we are talking about. The direction of travel of wave is what we actually talk about the ray. So let's understand wavefronts more. Now all these are the same things, they will confuse you. Yeah, so then when you look at this at a far distance away, I'm just going to skip some of the slides here. Yeah, from these examples we conclude we're talking of a uniform medium. First of all, we are not changing the medium so far. We will change the medium. So look at this, right? So far away, if you look at this, it's a flat wavefront, and rays of light are perpendicular to that, and that is why they're actually parallel waves rays of light, right? So let's look at some examples by drawing ourselves. So if the wavefront was this, now rays of light are perpendicular to the wavefront, right? So perpendicular to this, 90 degrees here, 90 degrees here, right? 90 degrees here. This is a diverging rays of light, right? Now if you look at this, this is a sorry, I made the same thing. Now if you look at this, you will actually see the rays of light are converging here, because 90 degrees here, 90 degrees here, 90 degrees here. These are not mirrors or lenses, these are just the wave fronts. So if you have this kind of wavefront, the light is actually converging here. But if you have this wavefront, the light is parallel. This is a parallel source of light. Right, this is the wavefront. So either you draw the wavefront or you draw rays of light. We are going to do both of them. When we try to understand reflection, refraction, we're going to draw both of them. Any questions, please ask me. Nobody is asking any question. Any doubts? Anything that is not clear yet? Okay, I'm giving 30 seconds for you to think about any questions, else we'll move on. Okay, now let's look at some of the types of wavefronts. So wavefront, actually, usually we draw one wavefront and the other wavefront lambda distance apart from that. Okay, so now we are drawing two wavefronts here. These are parallel wavefronts, these are circular wavefronts. In circular wavefronts, you will actually see, depending on if it is in this direction, so it's converging or diverging. I don't know what to speak here because everything I've already explained you. Anything that is not clear, ask me. But now look at this. We were talking of a point light source, right? Point Lelia. So what will happen is we were drawing circles, but it was all spherical. It was 3 dimensions, right? So let's go back here. I think some of you might not have got it. So I'm going to do that again. So in this case, let's say this is a point source of light. So things are not going to be traveling in 2 dimensions. It's like 3 dimensions, a sphere there. But think about a line source now. Instead of point source, it's a line source, like a tube light. So light will travel this way. It's going to be cylinders there. So look at the picture, that will explain more. So a line source of light is going to create cylindrical wavefronts, not spherical, but cylinders there. Right? So that is the symmetry there, the cylinders. Is this clear? Please tell me yes or no. Is this clear? Yes or no? Bolo bhai, clear hai? Line source will produce cylinders. Point source will produce sphericals. Spheres, I mean. ठीक है, clear है, clear है. Spherical wavefront is from the point source there. Yes. Vasudeva, what you're writing is 100% right. Yes. Seems you have already studied this. Okay. Now this is how we draw. Like we draw it like in flat because we don't have a 3-dimensional whiteboards and papers and pen and all that, right? But in reality, you have to assume that, that this is the kind of thing. And now you can see the farther you are, the less the curvature there. So these will look like flat sheets, right? So flat sheets there. Now this is what I already explained you. The farther you go, the less the curvature and straight those are. So from a source at infinity, rays are parallel. We have seen this in grade 10th actually. We have been doing that. Light coming from sun is parallel rays of light. Now we look at from the perspective of wavefront, we are saying, okay, the wavefront is a plane. Reflection and refraction of wavefronts. Yeah. So let's understand reflection and refraction. ठीक है, आगे चलते हैं. I think I will do justice by explaining you by drawing my pictures also. But look at these. These are nice illustrations here. So what's happening here is, so far we have seen, okay, ray of light comes here, angle of incidence equal to angle of refraction, right, and so forth, right? But now we are looking from this point of view of wavefront, and I'll show you, actually maybe I'll show you in the next page how you can prove that angle of incidence equal to angle of reflection, both the ways, using rays of light or the particle nature or the wave nature. Okay, just go through this. Okay, so now this is what we are going to analyze. We'll see spherical wavefronts, they're reflecting off the mirror. So let's look at it. Right, so lines perpendicular to the rays, right, wavefront, that's what you do. So I'm actually going to show you these slides, and then I'm going to make my own pictures to explain. So now reflection, let's see reflection here. Nina, let's please focus on what we are studying here, please. So when I ask you for doubts, you ask those doubts out of context here, please. Please feel free to ask, but not now, please. Okay. So now if you look at this, there is a ray of light that is coming here, right? Spherical wavefront. Yes, Ninad, please. We'll talk about it later, please. Okay. Now I think this picture is pretty clear. I don't have to make my own. So let's say there is a source of light here. Now this source of light is a point source of light. Now we already have seen what happens here. Let's see what we studied in grade 10th first of all. So we said, okay, there is a ray of light. Oh, so there's a source here, some object here. And what you did was you did, okay, let's say there's an incident ray here. Angle of incidence equal to angle of reflection, right? Everybody did this, right? I'm sure everybody did this. You would not have passed your 10th grade without doing this. Okay. Now then we said, okay, we need two rays of light. So let's draw another one. And these colors are just to illustrate here. They don't mean the color of the light. Oh, but then we say, oh, that's more like more angle of incidence, so more angle of refraction, right? So angle of incidence equal to angle of refraction, so light goes here. But these are diverging rays of light. So then we say, okay, let's make them meet virtually somewhere here, something like this, right? And then, oh, this was the object and this is the image. Everybody did this, right? Now we are looking from the perspective of the wave fronts this time. So you're saying, okay, there's a spherical wavefront, and this is what this represented, and that the spherical wavefront is going to go back. But then if you go back, so remember, if the wavefront is traveling like this, the rays of light are diverging, right? If the wavefront is going this way, so these were like diverging rays of light, and then when it goes this way, the diverging rays of light are this way, but then you got to converge them back. So anybody who has not understood this, please let me know, because I think I'm going a little faster than what I usually do. Now lambda will remain the same because it is the same medium. Velocity remain. Remember I said velocity is determined by the source. Sorry, is determined by the medium. So medium decides the velocity. Frequency is decided by the source. Now if velocity is same, the lambda it will be same, right? Yeah, but Nina, this is not going to be parallel, right? These are diverging, no? Right? It would be parallel if the source was very far away, right? So uske case mein, yeah, it would be these rays of light will be parallel because the wavefront will be flat. Yeah, Nina understood it. So there are so many students, nobody is speaking. Is everybody clear here? Abhiraj, Atri, Grishma, Abhinaya, M. Ashik, Manjushri, Mrunal, Ninad, Rhythm, Rupa, Rukaiya, Sai Kumar, Shreya Bhatt, Shreya Hegde, Trisha, and Vasudeva. समझ में आ गया, like everybody is clear what I have shown here. ठीक है, आ गया समझ में तो ठीक है. We'll spend more time in calculations like interference and all that. Reflection of plane wavefronts. Let's see how this works. ठीक है, waves आ रही हैं. Okay, Abhiraj has done this chapter, so he's actually more in the revision mode here. ठीक है. Now think about these rays of light. They're coming here. है ना? This is medium one. Let's assume this was air, and let's assume this is water. So when the rays come from air to water, what happens? Do they bend towards the normal or away from the normal? Can everybody tell me? Ray is traveling from air to water. Will it bend away or towards normal? ठीक है. Atri, you're right. ठीक है. Sai Kumar, you're right. Yeah, I will explain you how that works in case of wavefronts. Yeah, Vasu is right. Sai Kumar is right. So let's say this is the boundary. This is border. So this is air and this is water. So let's see how we can explain using wave theory why the light bends towards the normal. ठीक है, यहाँ से ले लेते हैं थोड़े से wave fronts. Wave fronts are basically, let's say it's coming parallel rays of light, right? So one ray of light here. So these are wave fronts. These are not rays of light. These are wave fronts. ठीक है, तो इसका मतलब क्या हुआ? This is the ray of light that we are talking about, but we are not going to show that until little later. Now look at this part here. This part has actually entered water, and in water they are going to travel slow. Electromagnetic radiation travels slow in a medium like water compared to air. तो अब क्या होगा कि this part will travel, let's say this much, let's say this travels this distance, लेकिन ये जो है this is going to travel a lot because this is faster, so this has come here now. ठीक है, I'm going to repeat what I said. So by the time this travels from here to here, let me color code that. By the time this comes from here to here, this is going to travel little less, chota distance, right? Because this is slow. Now look at what happened because of that. Because of that, the wavefront itself has bent. And it is a denser medium. So it travels more, it travels less because it is slow. So, but then as a result, what happened? Let's draw the ray of light. Ray of light is perpendicular to all this. And this was the incident ray. What happened after refraction? Oh, the ray of light has bent now. Now, if I draw the 90 degrees line there, normal there, you got to see what happened just now. The ray of light actually bent towards the normal. समझ गए? Everybody is clear? I'm able to show why the light bends towards the normal using the wave nature of light. And ulta bhi theek hai. Ulta isi diagram ko we can use it. We don't have to draw again. Let's say the light was going this way. है ना? This has started in the air. So इसने ज़्यादा travel कर लिया, more. And this will still travel less. But then what happened was the ray of light was going this way. It has bent away from normal. Right, so when it goes from water to air, it bends away from normal. So simple here. Clear? सबको clear है? Everybody is clear? And I'm going to draw my own diagrams. I think this is explaining you more. So let's understand what happens when it goes through a convex lens, let's say convex lens. Now, you would not have done your 10th grade without doing this. You would have done this, or the parallel rays of light, or they do this. Does everybody remember this converging lens? Hannah, you ratified it, memorized it, because you were not told the reason, right? Obviously, that's fine. That is all right, because at 10th level, we don't want to go to the wave nature. We say, okay, the rays of light come here, they concentrate at the focal point, right? But now let's see what goes on behind the scenes, why this is happening. Let's draw the rays of wavefronts, not rays of light. Ye wavefront aaya, right? You agree this is a wavefront coming from infinite distance, right? Infinite distance say you can draw like parallel rays of light, or you can draw flat wavefronts. तो आ गया, right? Wavefront आ गया. अब यहाँ से difference शुरू होगा. Let me draw it properly. And obviously we are talking of thin lenses, but I have drawn it thick to illustrate. ठीक है, यहाँ आ गया. अब देखो क्या हुआ. Just focus here. This point is traveling in glass now. This point travels in glass, it travels this distance. But look at these points here, these green dots. They are still traveling in here. They don't even enter the glass. So इनको क्या होगा? They are traveling so much. In the same time, they have traveled so much because they are faster now. और जो बीच के points हैं, they are traveling partly in air, partly in what? A glass. So वो बीच में आ जाएंगे. So ultimately, what will happen is this is your new wavefront now. Remember, the wavefront was plane. Now it is this. But then rays of light have to be perpendicular to that. So now let's draw the rays of light. This is one ray of light. This is another ray of light. What happened now is this. Oh, the ray of light has to go this way. It has to be perpendicular to the surface there. 90 degrees यहाँ पर, 90. And this is why they are bending and concentrating there. Anybody who did not understand God should ask me. I will explain again, no worries at all. So I'm able to explain why the convex lens focuses. अब उल्टा जाएंगे, concave lens after this. Clear? Right? Yes or no? Okay. Poll here. Clear means true. Not clear means false. Clear means true. False means not clear. No rectification, no memorizing needed, please. In physics, you don't memorize anything except few formulae and few facts and figures. You don't memorize things, you understand things. Okay. Now there are 22% students who are saying not understand, but then you got to ask me what part is not clear. Looks like a pencil. Kya pencil? Abhinay, what is pencil? Acha, this thing looks like a pencil. Yeah, Abhinay says this looks like a pencil. Yeah. Right? Yeah. So 22% students, I'll not take your name if you just let me know which part is not clear. I will explain again and again. We have enough time. Don't worry about time management here. So if you're not asking me, I'm going to move on. Seriously, I'm going to move on. You got to ask me and tell me what is not clear. तो यहाँ से एक बना दिया हमने concave. ठीक है? Let's see. Now in your grade 10th, you studied this. Diverging lens, yes. Right, when you trace it back, it ends at focal point, right? You studied this. Let's see why this happens. This happens because there is a wavefront, there's another wavefront, there's a third wavefront now. Look what happened. These ones are traveling in glass. So by the time they reach here, the center one would have moved very forward because it's traveling less in glass. So it moves here. So what happened just now is your parallel wavefront has become this shape. But now if you talk of the rays of light, the ray of light was this, the ray of light was this. Now it got to be perpendicular to that. So yes, it is a diverging lens. You can explain anything. You can explain prism. We'll do prism after this. We'll do concave and convex mirrors also. ठीक है? अगर ये clear नहीं है, you have to tell me. I'm not making an assumption कि क्या समझ में आया क्या नहीं आया. I'm really sorry. You got to ask me and I'll explain 10 times also. नहीं समझ में आया तो I'll call you. I'll definitely call you and explain. ठीक है? हमने क्या पढ़ा था? There's a ray of light that let's say हाँ यहाँ से light आ रही है. It bends. ऐसे नीचे bend हो जाती है, right? Remember that it bends like this towards the base. Yes, Abhinay, I'll show you the previous slide. देखो. Anything not clear, you got to ask me. Abhinay and everybody, you got to ask me. Oh, the previous. Okay, before this. Okay, ठीक है. This one. Pencil वाली पसंद आ गई pencil. Abhinay likes this pencil. Yes. Any questions here, Abhinay? नहीं, ठीक है. समझ clear? Everything clear? ठीक है. Sure. Okay. Now let's see prism. Prism में हमने देखा like ray of light goes here, bends towards the base. Why? Same reason, no different reason. ये wavefront है. This is another wavefront. Travel कर रही है, right? It's just traveling. Now look at what happened. This part is traveling in glass. By the time it comes here, ऊपर वाला तो portion सारा air में ही जा रहा है यार. So it's going to travel more, or maybe more, right? So now the wavefront is this. It's very obvious now what's happening here. I'm not showing what happens inside of it for just simplicity there. The waves have bent. Light bend ho gayi niche. Look. Right? So you can explain prism also now. You can explain this was all refraction. Let's look about like reflection. Reflection mein kya hoga? Let's say Distance between the rays is yeah. So if it is diverging, the rays are increasing, like they're दूर होते जा रहे, they're diverging. No, diverging means bhago, dur bhago, right? Diverge. Converging is they're converging at one point. Okay. Now let's look at the plane mirror here. Plane mirror में it's so very simple here. So यहाँ से रे आए, ठीक है, ये वापस जाएगी, उल्टा हो जाएगा. But let's this is simple. Let's do concave and convex. That's more complicated. So let's say this is a convex lens. Cut. Right? क्या पढ़ा था हमने कि ray of light comes here like this, right? यही पढ़ा था ना, like it's a diverging mirror. So let's see why it is diverging mirror. So let me draw with black color, because wavefronts I have been drawing with red color so far. I don't know why, but okay, this is a convex mirror, right? What would happen now is there's a wavefront here, there's a wavefront here, or paths बना देते हैं, so that we will make three like we have been doing. Now there is a wavefront that strikes here. Reflection हो रहा है, reflection. तो अब क्या हुआ कि this part has started traveling back. So this is going to be reflected immediately while this is still going on this side. And this is also traveling this side. So eventually क्या हुआ कि by the time this reaches here, by the time this they're all in here, there's nothing like change of medium, right? This reaches here, but by that time the red one has already reflected and come back here. So what happened to your wavefront now? Let me draw it with blue color. The reflected wavefront is this, isn't it? So let me try to be more creative and artistic there. It's ugly there, but then think about it. The wavefront was straight, it has bent now. But then if it bends, the ray of light which was actually coming parallel here, that actually goes this way now, because you got to be perpendicular to this line. You got to have 90 degrees here. So this is how the diverging mirror works. Last example we'll take is converging mirror. So converging mirror we already saw is this. So rays of light come here, they do this, right? They do this. So let's see the same reason. By now, many of you have already understood what I'm going to do now. So I'm going to draw the same kind of thing, and you can actually see what happens. So ये यहाँ टकरा गया already, right? This wavefront is already there. It's almost there, right? So these black dots, they will start moving backwards, है ना? So now they move here, but then this green part is still there. So what would happen is by the time this green comes here, these black dots have come here. So how does your wavefront look like? The wavefront looks like this. Right, very ugly diagram I'm drawing, but I'm trying my best actually to draw freehand. So this is your wavefront. So now your rays of light, which I'll draw with blue color maybe, were this, but then they got to be 90 degrees to this. This is your ray of light, and this is 90 degrees. I'm drawing 90 degrees to the curvature there, and this is your focal point.